Recording is rolling. It is Tuesday, August 19th. You guys had your algebra packets out. We're going to continue these. Remember, there were 7 sections for 50 questions. Okay. I saw some from part one with you guys, but I'll solve some more today. Guys, how it's been pacing out today is I'll do a couple here, a couple there through section 4. Okay. And then we'll do some tomorrow and the next day. So I'm planning to pick these up from you guys this Friday. And I'm still looking at putting give you guys a quiz, not this coming Thursday, but next week, Thursday. And remember, the way I put these quiz together is every day you go home, I'll review the video that I'm recording right now and find probably a couple questions that I think look interesting, and I'll start piecing the quiz together, question by question. Tomorrow, there's going to be an infrastructure test. Can you guys bring your laptops to school and have this ready? Period 2 tomorrow. So second period at 9:55. They're going to take us through a process. I think it's related to this fast testing, which is next week. I think you want to make sure that it's not going to crash the system with bandwidth and the whole thing. So speaking of fast testing, this is for 9th and 10th graders. A lot of you guys in front of me right now are 9th and 10th grade. You guys check that Excel file that I posted to Google Classroom yesterday, and it'll tell you exactly where you're testing. Now, if you're not testing, be aware some of your classes might be switching to another classroom. If that's the case, probably your PD will tell you. Okay, so all that info is right there. Here's another detail. You guys know that open gate system with the metal detectors. So they need teachers to volunteer approximately every week. So I've been signing up Friday mornings. So if you can't catch me Friday mornings, that's probably why I'll probably be working on things. All right. So you guys got packets. You guys got these algebra packets. Now, yesterday I was giving you guys some hints about these word puzzles right at the very end. And I want to go and modify something I told you guys because I was driving home yesterday thinking, you know what? I think I told them something that's not quite correct. Now I'm thinking of it. So real fast, let's go over to part 7, the very last 5 questions here. Number 46 and 50. Some I can point out here. So it's number 47. You guys see number 47? Says Alan, Bob, and Chad's ages are related. Chad is 3 times older than Alan. Bob is 2 years older than Alan. And 6 years, Alan and Bob's combined ages will equal Chad's age. How old is Chad, I think? Right. And what I was recommending to you guys, we're all aging 1 year per year. So whether it's now or in the future, the age gap between any two people is never going to change. Right. And so I was saying, well, maybe you should put in Chad's current age. But I was driving home thinking about it, saying, wait a minute, that's not actually true. That actually changes the question. And you would actually get a different answer. So whatever I told you to write here, go ahead and cross that out. We're going to keep the original phrasing of the question because you can actually solve it, but at least there's something different. And I'll show you guys why. Because that whole age gap staying the same only works if you have 2 people. If you bring in a third person and combine their ages, then it's a different dynamic. I'll give you guys an example. Suppose, for example, I'm just going to make up some values. We've got Alan, Bob, and Chad, something good. Suppose they were ages, how about 10, 12, and 14, just to make something up. Okay. And a couple of years from now, what are their ages going to be? So would Alan be 12? How old is Bob going to be? 14, and Chad's going to be 16 a couple of years from now. Yeah, just think a little bit. Right. Okay. No, if you're combining their ages and looking at a difference, it's different than one person to one person. Let's say, for example, what if I combine Alan and Bob? What's their combined age right here? 22? So, all right, 22. Maybe this is like Alan and Bob right here. Okay. How about in a couple of years? What's their combined age? Yeah, 26. See, it didn't go up by 2 years, even though it's a 2-year gap. It went by 2 plus 2, which is like 4, right? Okay. Now, if you take the difference between this and this, guys, what's 22 minus 14? Yeah, like 8. There's an 8-year gap between Chad and the combined Alan and Bob. Okay. What about 26 and 16? What's the difference? 10. Right. Notice that it did not say the same. Right. No, again, if you just focus on only Alan and Chad or only Bob and Chad, the difference would always be the same, but not if you combine them. All right. So it's a little different. So just cross out the word current. So oops. Yeah. All right. But let's rewind a little bit. So going to part 2. Guys, skip over to part 2. I got some puzzles started that I've been solving in class today. Yeah, my plan is to solve a couple here, a couple there, and then I'll do some from part 2, 3, and 4 today. And you should have about 15 minutes at the end of class today that I can walk around, answer individual questions, troubleshooting questions you guys have. All right, you guys can work with each other. You should have so we're working about half hour here. Okay, so number 15, find the slope of the line that passes through these 2 points. 15. So we got the points -2, 4, and 7, 1. So those ordered pairs, those coordinates. Okay. Now, I'm going to solve a few. Well, there's a graphical way to look at this. There's some more equation formulaic approaches to this. And even though it just says find the slope, I'll go ahead and get the whole equation for this too. So we got these ordered pairs. I'm going to start by making a graph so we can get a good visual for this. Like, what does this look like visually? Okay, and then we'll do some other ways of okay, that's great. So you got an x-axis here, you got a y-axis here. Let's go up to 1, 2, 3, 4, 5, 6, 7. At least we need 1, 2, 3, 5, 6, 7. And how about 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So okay. You go back this way. All right. Okay. So you guys got an axis system. All right. In your notes, everybody does have some paper out, right? This paper. Okay. Some of these might be able to solve right in the packet. Some of these might need your notebook for extra paper. Okay. So can you guys plot these 2 coordinates? Go ahead and do it. Stay a step ahead of me. Give you guys a head start right here. Okay, plot those 2 coordinates on the graph on that grid system you just drew. Right. So plot those 2 points. Plot those 2 points. Stay a step ahead of me. Okay. So -2, 4. Where is that? 2 to the left, 4 up. That right. Bam. Right there. Right there. -2, 4. -2, 4. Right there. Where's 7, 1? 7 to the right. Yeah. 7 to the right. 1 up. Bam. Right there. 7, 1. Okay. That's the 2 coordinates, isn't it? Okay. Okay. Oh. I have 2 lines. Can you draw a straight line between those 2 lines? You guys got rulers? Okay, please grab a ruler. A ruler on your desk. That's the line right there, isn't it? That's the line right there. Okay. Now, the question was about slope. We'll get a full equation. Hold it. Here, let's say I got a little stick figure right here. You guys see this little guy? He's walking left to right. Okay. But as he's walking left to right, is he walking uphill or downhill? Down. Downhill. And that tells you what about the slope? The slope is negative. It's negative slope, isn't it? Right? So, slope. All right. Let's think about slope. All right. What is slope? It's what over what? Rise over run? Yeah, rise over run. Right? Okay. Now, we're going to take this and maybe make it more mathematical. Like in terms of x and y, it's what?
M equals B.
Okay, yeah.
Closer. It was M equals B plus Y. Oh, no. B over Y.
Okay. Oh, you guys are hitting all around this. Yeah, it's change your y over change your x, isn't it? What? All right. Oh, yeah. Let's get this over here. Okay, so heard you guys say a few things. I think you guys are trying to eventually get towards something like this, right? The slope intercept. Oh, I should have asked you guys. This is called what form of a line? Yeah, slope intercept, where m is the slope and b is the y-intercept. Slope intercept. Right, y equals mx equals b. Right. So we're sort of working towards that. Okay. So you guys said change in y over change in x. That's how you use it. Change in y over change in x. And you guys are saying, okay, that's like y2 minus y1 over x2 minus x1. Okay. These are all saying the same thing, aren't they? Okay. And what's the character in algebra for slope again? M. Yeah, there you go. M is slope, usually. Okay. All right, so, hey, we have a couple of coordinates here. So I'll say M, the slope, is, suppose this is 0.2. So what number goes for right here? 1. So y2 could be 1 from right here. What's y1 then? 4. Aha. Right. Over, or compared to, what is x2? 7. And what's x1? -2. So can you subtract a negative? You guys do that? 7 minus -2. Okay. So the slope comes out to what does that reduce? What is that? -3 over 9. You guys are saying, right? Right? You guys have that? And what does that reduce to? -1 over 3. Huh. let's see if that's true. Let's go back to the stick figure guy. You guys see the stick figure guy? Okay. Let's see what we just did was we said if we go across so many units this way and down so many units this way. You guys see that if you say go across 9, you would go down how many again? 3. Like -3 like that. Is that change color? Okay. So if this guy steps forward 3 feet, how far does he fall down? 1 foot. So it's like across 3, down 1. Or you say like down 1/3, down 1/3. That's exactly what this is, isn't it? Down 1/3. Right. That's the answer to the question. So the slope is -1/3. Okay. I see down 1/3. Right. You guys good? Okay. Now let's go an extra step. Guys, where is this line crossing the y-axis? Between what and what?
3 1/3.
Yeah, between 3 and 4, somewhere in there, right? Okay. So let's get an exact equation in slope-intercept form. Now, there's more than one way to do this.
Yeah.
Do you guys remember something called point slope? Point slope. Okay, I'm going to use that method because I've just been doing that today, so just to keep it consistent. My earlier classes. So I'll spell it out. Point slope. Okay, so that's like y minus y1 equals slope times x minus x1. Okay. And so it's the same question. I'm just getting the exact equation. It's the same one. Okay.
Wait, that wasn't the answer?
Yeah, that's the answer. Okay, guys, the question was what's the slope? We got it. Okay. But I want to go an extra step. I want to get an exact equation for this line. Okay. Okay, so yeah. Okay. Do you guys see if you take this x minus x1 bit and you divide it over, you get change in y over change in x is equal to slope, which is kind of what we have right here anyway, isn't it? So start from this, you can rearrange that, get a point slope. Okay. So now y is just a variable y. I need a point to plug in. I'm going to plug in this point right here. You see 7, 1? So in place of this y1, I'm going to write what again? 1, because the 1 was the y coordinate. Okay. And then slope. Ooh, guys, what goes in for slope?
-1/3.
-1/3, because we just found that. And that's times some variable x minus, what goes for x1? Yeah, 7, because the 0.71, that's one of the coordinates on the line, right? Okay. All right. Can you guys finish solving this and put it in slope intercept form? Got a few steps. I'm gonna give you guys a head start. Here, walk around the room, see how you guys are doing. All right, so you guys are gonna do an algebra process to get that in the form y equals mx plus b, because that's what slope intercept is. You guys are doing some algebra right now to get that in the form y equals mx plus b. What you guys are doing? All right. So did you guys distribute this -1/3? It's one way to do it.
Yeah.
So y minus 1 equals -1/3 x. What is that plus 7/3? Is that what that is? Okay. Ooh, should I add this 1 over? You're like plus 1 plus 1. Okay. Oh, how do you do 7/3 plus 1? You need a common
Denominator.
denominator. All right. Here, I'm gonna draw some pizzas. Let's get some pizzas going. So we had a big old pizza party last night. We came back and look at all these pizzas. And look, they're all cut in thirds. They're all cut in thirds. I'm just giving you guys a visualization here. They're all cut in thirds. 7 thirds. 7 thirds. What is that? There's a third, a third, a third. There's 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds. 7 thirds. And then there's another pizza. Oh, somebody put one in the fridge. There's 3 more thirds. Guess how many thirds is that altogether? That's 10, isn't it? Okay. Now, in terms of common denominator, the number 1 can be written as what over what? Yeah. How about 3/3, right? 3/3. Okay. And look at there. That's 10 thirds right there, isn't it? So put it all together. This says y equals -1/3 x plus, and what goes right here? 10 thirds. Oh yeah. Okay. There's your slope intercept form right there. Okay. Now 10 thirds. What is that as a decimal?
It's like it's not a number.
3.33.
Yeah, there you go. 3.333 something. Right. That should be the y-intercept, right? The y-intercept. Wait, is that really true? Let's find out. Moment of truth. Moment of truth. 3.33. Oh yeah! Look at that. It's right there. Right there. All right. So you guys get on 15. Good. All right. Alright, next one I got started. Let's do number 20. Guys, see number 20. It says graph this inequality. Number 20, inequality time. So I got number 20. Y is strictly less than negative x plus 1. Right? So, same as before, I'll get a set of axes going. But before I draw it up here, I wonder if you can draw it correctly first. As if you can get this before I do. If you can get this before I do. That's a good indication to both of us that you know what you're doing. Gotta find out who my winners are. Wait, you guys see that inequality says y is strictly less than? What if it wasn't equal? Could you guys imagine y equals, like equals negative x plus 1? Okay, could you make a line out of that? The graph? Right, because you sort of start from there. And then there's something else you have to do.
What am I graphing?
This right here.
Those are numbers though.
Okay, so you got an X, you got a Y. Guys, this is slope intercept form, right? Is that kind of what we just did? Slope intercept form? Okay. You guys have. Okay. So, guys, if this is like slope intercept form, what's the Y intercept right here? What's the Y intercept? Yeah, 1. You guys see, like, if you plug in, another way to get that is anything that crosses the Y axis, what's the value of X right here? 0. So if you plug in 0 for X, see how like Y is 1? Okay, now it says less than. We're going to come back to the inequality. But basically the point 0, 1. So you guys see this point right here, 0, 1. That's like the Y-intercept. Okay. And if this is slope intercept form, guys, what's the slope of this line? Negative 1. Yeah. It's like down 1 over 1, down 1 over 1. Okay. So there could be the point 1, 0 here. Right, down 1 over 1. Okay. So does the line basically go like this?
Yes.
Like that? Okay. Now one more detail before I draw it in. Okay. Look at that inequality. We're going to come back to that. See how it says strictly less than? It doesn't say less than or equal to. It says, whoa, guys, careful. Okay. It says strictly less than. So, are you allowed to include points that are on this line?
No.
Right. The answer is no. And how do you represent that on the graph? Dash it. Aha.
Okay.
Dash it. So, you just hold your ruler up to it and go like up, down, up, down, up, down, up, down. Go. Dash. Yeah. A smooth line. Okay. Let's make sure this works. Because guys, what I'm saying is, how about this point right here? You guys see the point 1, 0? Which is like right on the borderline. Does that work? What's negative 1 plus 1? 0. So it kind of works here. Okay. Now, guys, strictly less than means you still have to do one more thing. You have to do what? Shade in what? See, if it's less than, is that everything above or everything below? Below. Aha. Okay. All this right here is all part of the solution. Okay. Yeah. It's all coming back. Yeah. Gotta rewind. Wait for some. Okay. So, I should be able to pick any point, and it should agree with that original statement. For example, what about this point right here? Is that the point 0, 0?
Yeah.
Let's see if I plug in 0, 0. Does it make a true statement? Let's find out. If I plug in 0 here and 0 here, is 0 strictly less than 0 plus 1?
Yeah.
0 less than 1? Yeah, that sure is. So it works. It works. What if I plug in this point right here? Is that going to work? What if I plug in this point right here? Is that going to work?
Yeah.
What if I plug in this point right here?
No.
What up here like 7, 7? That doesn't work?
Nope.
So let's see if it doesn't. Are you sure?
No.
Let's see. What's negative 7 plus 1? So negative 6. And then negative 7 is negative 7 less. Wait, hold on. Yeah, I'm so sorry. Yeah, 7, right. Is 7 less than -6? No, okay, yeah. Okay, so right there you go. So all the shade works. Everything not shaded above doesn't work. Okay. Is that okay? All right, let's see what we got next here. We got next. Okay, let's go on to part 3. Part 3, systems of equations. Number 27. 27. Solve the system of equations. Now, it says by graphing, but I'm going to do different methods with you guys because there's several methods to solve this. So number 27, I have y equals x plus 1, and also y equals -2x plus 4. Okay. And this is a system. It is y equals mx plus b all over again. Yeah. Okay. Now it says by graphing, and well, I wanted to do that first anyway, so let's do that first. Let's graph this thing. Ooh, now I'm gonna make 2 graphs. Well, 2 lines. 2 lines. Ah. Guys, make an x-axis, make a y-axis. Let's go ahead and graph both of those. Here, it's walk around time. You can graph those 2 equations. I'm gonna get some winners. I'm gonna get some winners. There's 2 graphs. And there's one of them there. Alright, you guys are off to a good start. Some of you guys got the first one. So we got the 3D for.
No, I've never been. I'm completely. Yeah. Oh, I did. It's like geometry and algebra. Yeah.
Alright. So, yeah, you guys are using this as a model, right? Great. So, y equals mx plus b. Guys, all the content, even the physics classes I teach, we use this all the time. All the time it shows up. I mean, this is a good go-to to memorize. When you see something in this form, this plus b, represents the y-intercept. Anything in front of the x represents how steep is the slope right here. Right? So, and you can pick any point on the line and verify it'll make a true statement. So, this first one, what's the y-intercept of the first one? Yeah, 1. And that's like the coordinate 0, 1, isn't it? It's not like right here, bam, 0, 1. Oh my god, I should have thrown some numbers on here. 1, 2, 3, 4, and so on. Okay. 2, 3, 4. Okay. 2, 3, 4. Right. And guys, what's the slope of that first equation?
X 1.
Yeah, isn't there an applied 1 in front of this x? Isn't there like a 1 right here? Is that like 1 over 1? Like up 1 over 1? Right. So, rest of the graph, does that look like this right here? Like that? Okay. See this little guy walking uphill? Does he go up 1 over 1, up 1 over 1, up 1 over 1? Yeah, right? Up 1 over 1, up 1 over 1, up 1 over 1. Yeah. Okay. Well, that's the first one. That's the first one, right? Okay. Here, let's put this to the test. For example, how about this point right here? Is this the point 2, 3? 2, 3. Okay. You guys see how that point lands on the line? What I'm saying is, you can take any point. I just picked this point randomly on the line. You can pick any point on this line, plug it into the original statement, and it should be true. So if I plug in 2 for x,
right?
Guys, what's 2 and plus 1?
3.
3, which is exactly that coordinate. You guys see that? Here, guys, if you ever run into trouble with these, can you do this? Okay, could you make a table of values? Plug in x is 0, 1, 2, 3. And then 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Do you guys see how all those coordinates line up on this line right here?
Make sure this isn't 100.
Right? Okay. Yeah, guys. Yeah, this is gonna show up in the quiz, right? Right? There's no way I can't put a straight line graph on a quiz. Right? Right. So, guys, you can always make a table of values. If you don't know what a graph looks like or something crazy, can you just plug in a bunch of coordinates and just plot them? Like, hey, look at that! It kind of makes that shape, right? How about this other line? Okay, let's try the let's try this table method because yeah, it's a different way of looking at it. Let's do an XY table. Right. I'll try. How about 0, 1, 2, 3? You could also go -1. Why not? If I plug in 0 for x to the second equation, what does that give me for y? 4. That's like the 0.04. That's like right there. How about if I plug in 1? What's -2 times 1?
Negative.
-2 plus 4 is
2.
2. The 0.12 exists. How about, okay, so I'm doing the second equation right here. Okay. What if I plug in 2 for x? What does this come out to? 0. The 0.20 exists. What if I plug in 3 for x? What do I get? -2. Right? That's like 2, 3, -2. That's right there. Bam. And what if I plug in, what if I go the other way? What if I plug in -1 for x? 6? Ah, that's right. Because -2 times -1 is +2. Plus 4 is 6. This is 6. Right? So look up here is 6, -1, 6. Take this point here. Right? And, oh, look at that! Look, all my points lie on a straight line. Look at that. Straight line. You see it? Right. What if you went with the slope-intercept method? Guys, this have a y-intercept of what? 4? Hey! That's right there. And this has a slope of what? -2. Is that like down 2 over 1? Down 2 over 1? So if I have the stick figure walk it left to right, so yeah, it goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Right? Right? Is it? Right. All right. Ooh, guys, look at where those two lines cross. What coordinate is that right there?
1, 2.
1, 2. Yeah. Is that the answer? 1, 2?
Yeah.
That's it. That's the answer. 1, 2. Oh, yeah.
They're the only same coordinate on the two different teachers or either side.
Ooh, you're right. You're right. Yeah, that's another way to look at it. Yeah, good observation. Yeah, that's the only coordinate that's, yeah, it's the same on both tables. Okay.
Is the quiz going to be on paper or on monitor?
I'll print you guys that paper copy. Yeah, I need to make it question by question every day. Okay. Now, guys, that's a graphical way to solve this. But there's other ways too. Guys, system of equations. I can think of at least 2 other methods. One starts with an S and one starts with an E. Yep. Substitution. Okay. And here, I'll flip the paper and we'll do this other one later. What starts with an E? Elimination. Yeah. All right. In this class, way later in the year, we'll do another process called matrices, but that'll be in the future. Okay. So substitution. Now here's my system of equations. Now, if y is equal to this, and then later on y is equal to this other thing, hey, isn't that like 2 perspectives on y? Y is this, y is this. Can I just set those 2 parts equal to each other? Because they're both y. Okay. So is just plain x plus 1 also -2x plus 4? Right? Okay. Do you guys see I just substituted out the y? I say, well, y is this, but y is also this. So therefore, they must be equal to each other. Right? Okay. Can you guys finish solving that? Okay. You guys, go ahead and finish solving that. See what you get. Oh, damn. Okay. Should I, what are you gonna do here? Can I do plus 2x plus 2x? That gives me 3x plus 1 equals 4. And then what? Yeah, -1. So now 3x is 3. Now what? Yeah, okay, yeah. Divide by 3. Oh, what's 3 over 3? 1. Okay. Now x is 1. Okay. Now, should I be able to take this answer, plug it back into either one of these equations and get the same value for y? Let's see if that's true. Let's try the first one. Guys, what is 1 plus 1?
1, 2.
2? Y is 2? Okay. How about the second equation? Let's plug a 1 in here. What's -2 times 1? Plus 4.
6.
-2 plus 4 is
2.
2. It's the same thing. It's the same thing. And as a coordinate, how would you write that? 1 comma 2. 1 comma. Hey. Oh. 1 comma 2. That's that point right there. It's the same thing. It's the same thing. You guys got that? Yeah. Okay. Yeah. It's a graph way, it's a substitution way, but of course, say conversion, the same answer. And are you guys ready for elimination? Elimination. Okay, I'm gonna rewrite y equals x plus 1 and y equals negative 2x plus 4. Here's my system. Right. Guys, are you allowed to add an equation to another equation?
Yeah.
Yeah. Or what about the other way? Could you subtract an equation from an equation? Is that a valid step? Yeah. All right. I'm going to do this. I'm going to subtract this bottom equation from the top equation. So I just throw in a negative around the full equation. Okay. Guys, what is y minus y?
0.
0. I just eliminated the y. Right? Elimination, which means I'll have one variable left on the board and I can solve for it.
Yeah.
What is x minus negative 2x?
X.
3x. Ah, 3x, right? Okay, so is that the same thing as x plus 2x? I think it's just positive 3x, right? Because minus a negative. Is that like plus a positive?
Yeah.
Okay, right? And then what's 1 minus 4? Negative 3. Okay, can you guys solve this?
Yeah.
Add 3. So 3 equals 3x over 3. Okay, it finishes out the same way as before. 1 equals x. Hey, we're getting the same thing we did before. And then you could sub this back into the original statement and get y, of course, is equal to, what are we getting? 2? Get 2 is y. Okay? All right, is that okay? Now, it's the same thing we got with so there's 3 different ways to solve that system of equations. Got a graph, got substitution, got elimination. All right, you guys can solve system of equations? All right, ready for the next one? Boom! We are winning. All right, let's go to number. Okay, guys, I'm going to do 3 more with you guys, and they're in part 4. So let's do number 30, 31, and 35, and then I'll give you guys the last 15 minutes of class, and you guys can.
Which one?
Number 30. Number 30. So it says exponents and polynomials. So number 30. Okay, I have x to the power 3, y to the power 2, and that whole bit is all raised to the power of 4. Okay? Yeah, good. Now, I'm going to do something a little funny here. I'm going to write this out in a crazy expanded form. Guys, this is the same thing as x times x times x times y times y. Is that what that is right there? X times x times x times y times y? Right? Okay. And then when I say to the power of 4, ooh, is that multiplied by itself like 4 times altogether? So it's like another x, 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 y, y, x, 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 y, y, x, 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 y, y. Of course, x and y might represent, I don't know, like 2 and 5 or something. They could represent numbers, maybe. Okay. But if you stand back and look at it, how many total x's are there? 12, because 3, 6, 9, 12. You guys see 12 x's all multiplied together? It's like x to the power 12. And how many y's do you see? 2, 4, 6, 8. Yeah. Is that like y to the power 8? Okay. Is that the answer right there? X12, y8? Yeah?
That's so smart.
That it? Right. Now, okay. When you're solving these yourself, do you want to write this out this expanded way every single time? No. That kills too many trees. So what's the general rule? Let's come up with a general rule. How do you go from this straight to this? Multiply the exponents. Guys, when you have an exponent to the power of an exponent, 3 times 4, 12, boom, done. 2 times 4, 8, boom, done. Okay? Can you guys do that? Let's do that? Yeah. Okay. Number 31. 31. Next one. 31. I got 12, a to the power of 5, b to the power of 3, all divided by 4, a squared, and then a b in the mix. Okay. I'll do what kind of what I did before, so expand this out crazy way. Guys, can 12 be 3 times 4? Is that okay? So I do 3 times 4. A to the 5, is that like a times a times a times a times a? And then b times b times b. It's all divided by, say I got a 4 down here. I got an A and an A and then 1B. So that's basically that, isn't it? Okay. Now, since everything's multiplied and divided, there's nothing added or subtracted. It's all straight multiply and divide. Can I do some canceling right here? Cancel time! And what do I have left on the board? I have a 3. I have now 3 A's that are multiplied. How can I write that? A to the 3. Okay. And I also have a couple of B's. I can write that how?
B to the second.
There you go. B to the second. B squared. Is that the answer right here? Okay. Right. So now that's the answer. But let's see. Is there a fast way? Is there a rule where you can go straight from here to here?
Yeah.
So guys, what's the rule?
You subtract
Subtract the exponents. Okay, so 12 over 4, of course, is 3. But yeah, a to the 5th over a squared, yeah, subtract. 5 minus 2, that gives you 3. That's that exponent. Then over here, b to the 3, and then, well, there's an applied 1 here. 3 minus 1 is 2. Okay? You guys got that? You guys do exponents? Okay. All right, one more I'm going to guide you guys through. Here's the last one to guide you guys through. Right. Number 35. 35. Right here. 35. Okay, so divide this. 35. I've got x squared minus 5x plus 6. And that is all collectively divided by x minus 3. Okay. Now there's more than one way to do this, but I'm going to stick to what I've been doing all day today, which involves factoring. Right. So do you guys know how to factor that numerator? And I'll get you guys started. It's something times something ends up being that. Okay, and I'll keep the denominator as what it is right here.
x times x I times.
Ooh. Okay. Yeah, something to do with the guys. Does this look familiar? Like throwing an x and an x here, something like this, like that. Does that look familiar? Yeah. All right. Okay, I'm gonna write these words down. I'm hearing some that yes and some no. I'm gonna write down the word factoring, which is what we're doing to go from what we started with to what I'm half written here is a factoring process. Okay. And the reverse process, if I want to go from this bottom step back to the original, okay, is that called FOIL? We go backwards. Okay. Guys, these two processes, factoring and foiling, are reverse processes. So you can go back and forth. You can check your answer. Okay, that's what we're about to do. Okay. So here, you guys remember a question like this? Like, what are two numbers that add up to -5 and multiply to +6? -2 and -3. Guys, watch this. -2, -3. Okay? Okay. Now watch this. What I'm going to do is I'm going to do FOIL, FOIL, starting from the answer. I'm going to work backwards, and it will give me what we started. Okay? Because FOIL, oh, I forgot to show you guys FOIL. If I have some generic A plus B and C plus D, kind of go first, outside, inside, last. That's what FOIL stands for, right? First, outside, inside, last. That's like AC plus AD plus BC plus BD. That familiar? Something like that? That's FOIL. Okay. So let's see if that's true. So first, outside, inside, last. Guys, what's x times x? X squared. Point. Okay, that looks like that. Right? Let's do the outside and the inside. So what's -3x minus 2x? -3x minus 2x is -5x, which looks like that, doesn't it? Okay. And finally, last. So I just did the outside, inside. Okay. Last, what's -2 times -3? +6. You guys see that too? +6. All right. Now, there's other ways to go about this too. We did kind of a guess and check version of like what's two numbers that out of this multiply to this, right? There's a more formulaic way to do this. Do you guys learn something called the quadratic formula? Yeah. You can also use that. But we'll probably say that for a different day. Okay. But okay, now that I got this, hey, do you guys see how does this reduce? Can I do this? Can I do that? Sure can. Okay. So is the answer x minus 2? Right. With one more condition. Right. So the answer is x minus 2, but x cannot equal X cannot equal what?
Negative.
3. How'd you know 3? Well, okay, kind of. Guys, what are you not allowed to divide by in a calculator?
0.
0. Because, for example, what is 5 divided by 0?
Yeah.
And don't say 0. Ah! Lose up the calculator. Yeah, can't divide by 0. Don't be divided by 0. And if you did have x is 3, then you would be dividing by 0, wouldn't you? So this is the answer right here. And here, I'll draw you guys a little graph real fast too. Okay. So what would this look like as a graph? X-axis, y-axis. Y equals x minus, if this was a graph, it would y equals. Would it be basically x minus 2? Doesn't that look like this? Isn't this y equals x minus 2? Right. But x cannot be 3, so there'd be a hole in your graph. You guys ever draw a graph that has a hole in it like this? Right? That's exactly what that is. That's exactly what that is. Which is the same thing as this original expression. Guys, if you plug this whole fancy looking thing into a graphing calculator or Desmos, it would give you this line with this hole in it. Okay? Yeah, you can use graph calculator. Yeah.
I don't have one.
Yeah, I don't either, but you guys have laptops and Desmos? Right? Yeah, you do that.
Yeah.
Alright, so that's as much as I'm doing today. Yeah, guys, we have some class time. So for the rest of the class, you guys can work by yourselves, work with each other. I'll walk around, answer any questions you have, and then we'll keep working on this tomorrow. Well, I'll be around to help you.